Hello everybody, welcome to another stream. How we doing? So last stream we what did we do? Yeah, okay, so we was preparing for the material editor basically. So this is the thing we'll be building which will allow us to procedurally create textures inside the engine, specifically for like ellipsoids basically, right? And we're going to be able to create a prototype material that will expose certain properties, and you can then not have many different instances of that prototype material, and you can drag the sort of sliders around and whatever and produce different materials, but they'll be quite similar. And the other is going to be quite easy to use and integrated within the engine. So we revised this plan basically all of last stream, and we got started off on the project restructure. So just restructured the project so it would make sense because we have like multiple applications, and everything's in the code directory. Now there's an apps folder with all the different applications, and then a modules folder for all the other bits of code that just gets shared between all the different applications. And there was some other small things as well. And so today what I want to do is get started on this task here, which is having the ability to have these shader packs essentially. So a SPV file, so load in multiple SPV files. Right now we only have one for the game because we only have one shader file, and it's about 5,500 lines of code. And I want to make it such that each material, or each prototype material, or for short proto materials, you get one shader file per proto material, and that means that it can generate whatever textures it likes. And essentially it's like a plugin, but with shaders. And so we need to add support for this into the GPU system. And we also want to add the ability to have hot code reload in shaders, because we're going to be building an editor where you can sort of edit materials and things. So being able to hot reload the shaders makes it such that we don't have to close the editor down and rerun the game basically. So it's going to be very powerful, and it will work. I'm not sure why I didn't have this earlier basically. But yeah, I've gone and sort of planned out this whole month's worth of work, so we should just be able to sit down and mostly execute and have very little surprises. That's what we was doing last stream. But all in all, this is probably going to take a couple of months to get the whole material editor done. But it'll be super powerful and awesome when it's done. So let's get started on the task for today. If anyone missed the... There we go. If anyone missed the planning work, it is on the VOD channel, those interested. Okay, so first of all, let's start by adding shader packs. Or, I could call them like a shader library or shader binary maybe. Shader binary? Shader binary might be a better name. Let's rename the stream. There we go. So right now, when you boot up the game, I think it's in Vulkan. Oh, so we do a create shader module. Yeah, there's a GPU shaders path. We're going to get rid of this. Oh, I didn't do that. Right, it's just in two places. Okay, so the idea is that in GPU, we want to have the ability to create shader binaries. So we need so when you create the shader the GPU system, we probably need a way. And then maybe we could make it part of this. Core define ID. So then we can have an object pool of these things. GPU shader binary ID. And so you probably have the default one for the game. But the rest of them you can sort of create and... Yeah, maybe. So perhaps you'll pass in a path into the initialization. So this would be like the... This would be the shader binary path. Something like that. Yeah. Okay. So we'll probably make a, let's make a separate section for this. And to be honest, it's probably got to go a bit higher up. But this would be the shader binary. So you need a way to be able to basically load a new one. So you probably just want to pass in some... Now, it can fail for a few reasons. But I guess it just return a null ID or something if it fails. We won't really give a failure reason, I guess. But you need a way to DN it. And then you need a way to... So above the dispatch, it needs to really get put in here somewhere. So I guess below the textures. Pretty good idea. So I wonder what else you want to be able to do. You probably want to be able to get... Let's make a structure to pass in a bunch of stuff. So GPU shader binary spec. So you probably need a list. You need the path for the binary. You'd also need probably a list of names. So this would be shader entry point names, something like that. And then you have or you probably just say shader names. Shader entry point names, okay. Shaders count. That'll be alright. So we can always add more stuff when we need it. So that'll get passed into here. Nice. So you probably want a way to... You probably would like a way to be able to look up a name and get back a shader index or something. Or we should call it find shader, right, and it gives you back an index. Two secs. My son's decided to sit up. Let me just help him get back in a good position. Be right back. Yeah, I think he's having trouble getting to sleep, so I might have to go and help him in a bit. Find shader. Yeah, we could call it a shader ID, but shader index, there you go. So returns U32 max on failure. Something like that. That'll be right. When the shader doesn't exist. Right, so I wonder what else you really want. So the reason why you have this made in the first place is because when we do a dispatch now, we want to have another one where you can dispatch from a binary. So, right, this takes in like a HCC shader. Right, we'll probably rename this. So this is just an enum, basically, precompiled enum. Well, it's a code-generated enum from my compiler, basically. It's quite alright. Does the job for now, but now it's just going to be shader index. And now we'll do another one where it's going to be GPU shader binary. And that should hopefully do the job. So you also, yeah, so, okay. So when we kick this off, we probably want shader binary spec. All right, jobs are good. And so now, guess let's start off by implementing some of these functions. So in GPU init, so what we want to do so you could probably have in the GPU side, you want a GPU shader binary ID. This would be that sort of primary or the default ID. Now you need a shader binary pool. So we need to create a pool so this is going to have all the bits in it that we need. There's the ID that goes first, right? So it's ID. Then we can do shader binary pool, sorry, object pool, GPU shader binary. So this means at runtime we can allocate and deallocate different shader binaries. Should be nice and easy. And we probably want like a maximum number of loaded shader binaries as well. So in the spec here, shader binaries capacity, right? So that'll be somewhere here. So shader binary pool, shader binaries capacity. Now we call that function, which is GPU shader binary init. Now we pass in the spec. So spec shader binaries. Shader binary, take the address. Then the result gets stored into that default shader binary ID. Just like that. So that should never fail, although it probably can. So we would like, so if you fail to load it here, so you want to be able to probably whack an assert down or something. Could not load shader binary. Could not fail to load default shader binary at this path here. So that'd be GPU shader binary. Oh no, sorry. Spec shader binary path. Nice. Cool. So the next thing to do would be to probably get these working. So underneath where this is implemented, we're going to add the shader binary section. Got to be very careful with this. So, right, this one's going to do one of those shader binary core object pool allocate. It's going to allocate from that GPU shader binary pool and get back a pointer. No. Oh, the ID goes second. Whoops. Okay. Rightio. So then we'll just return the ID like so. But this can possibly fail. Basically, well, when we try, I guess we'll call into the back end and say, hey, try and create this given this spec. So maybe we'll sort of like allocate all the bits of memory for this. So yeah, I think actually we're probably going to want to store a bunch of like name. Well, let's not do the name thing for now. I'm not really interested in that feature. So I guess let's not implement it because it's just extra time it takes to get this up and running. So what we need to do is in the back end create another function which is going to be shader binary in it. So you pass in the shader binary and maybe the specification as well. Something like this. Now, so I'm not sure why I put const in there, not gonna lie, I usually hate the crap out of const. There we go. Then the DNet will just take the binary in. And we'll need a way to say reload as well. Because we'll be doing the hotcode reloading, right? All good. So we'll get those implemented in just a bit. Let's go ahead and get them plugged in here though. So the first thing would, oh yeah, so this one can fail. The initialization can fail because the file won't exist or whatever, or be an invalid whatever. So like invalid binary or something like this. So that'll be core ID null GPU shader binary. So the initialization will be binary and spec. Nice. And then for the DNet, we'll just do a get to fetch the binary. Then we shall say GPU backend shader binary DNet. So in the Vulkan backend, I'll do that. And then we actually want to deallocate it from the pool. Right. That's okay. Nice. So there's one more thing that we want to do in the front end, I think, and that is doing the reloading. Now, and then we can just do all the stuff in the Vulkan backend. So we need a few things in here, like we need the backend information, which usually some sort of like opaque thing. Just an opaque set of bytes, basically. Shader binary, backend size. We'll figure out exactly what we want in a bit. Okay. Shader binary backend size. So it just means we can take the pointer to this and then cast into to the backend structure, and the sort of backend header doesn't have to be exposed, basically. And then we want to probably store some form of like time stamp here. I don't have I done one of these yet in the OS? I don't think I have. So we'll probably have to add support for this. Now I've got to figure out. So if we use stat on Linux, right? So st strut. Okay, why am I using this? Man stat 2stat. Yeah, 2stat gets you the standard library. Sorry, the C standard library implementation of it. So there's a structure on here usually. Yeah, strut stat. Is there another page? Hmm. How do you get access to the... Oh, okay, I guess they're kind of listed here. The st underscore. Right, so there's a stat 64. I think you can get the timestamp from this. Let's just look in the editor, I can't find it. So I did strut stat. Right, where's that in again? Oh, sysstat, okay. Alright, let's take a look at that. File mode. Right, there's a time spec. Time of last access. Time of last modification, that's what you want. So we can convert that into a time. So what is it? Nanosecond resolution timestamps are stored in a format equivalent to time spec. What is it? Since... I guess it's since 1970, isn't it? Okay. So we need a way to expose some of that via the OS layer. We want to get the sort of last modification time. How do you do that on Windows? Win32, get file modification time. Right, creation access rights. That's what you want. So I guess every so many seconds or whatever, we can just check this. Or every second or whatever, you know. And we'll just use that for now. There are ways where you can, rather than polling it yourself, you can set up systems that will, where you can watch a file and receive events for it, but that's more involved. This is really easy to implement. So we're just going with this solution for now. So let's go to the OS layer. We're just going to chuck in a way to get the OS file last write time. So the last write time. Now I think I've done this in core, is it? I've got this sort of time. Yeah, I don't know if I implemented these. I don't think I did, which is okay. You have not implemented these yet, but this will still be fine. We can still do. No, I might have to implement some of these actually. Damn it. Okay. Well, there you go. So OS, so core time it's going to be called. So return a core time. So we can implement that on. Okay, so there's a Windows version and a Linux version. Good, good, good. So so yeah, I guess we'll just make a time equals just zeroed like that. Say t like that. Cool. Now here we'll populate t dot seconds with s dot st a time. Is that it? I forget. No, it's access time. M time, obviously. Modifier. Right. Seconds, then nanoseconds. And return t. So that's the Linux one. Then for Windows, we'll do a very similar thing. We're going to use this get file time. I guess it returns true. Yeah. So if is that I've got to open a file? Yeah, I've got to open up a file handler, isn't it? Obviously. So is it create file, isn't it? Got to be really careful with this. These are always very fiddly. So yeah, so open up a file. So share read. Is there anything else that you can do? The generic read. Crap. So there's a share mode. I guess we'll just say share read. Then where's the generic? Then desired access. Okay, where's that one? Second one in. generic read. Oh. I was looking at the wrong one. I don't know, there's a 0 in it. Okay, generic read. Open existing. Yeah, in this case, we want to get the last write time, so open existing. I think that's okay. So now that will return a invalid handle if it fails. So if handle equals invalid handle, we'll then return some kind of like null entry. And then we get the time here. Now what is that time? LP file time. So they're optional, so you can pass in null. So null for creation, null for last access, and then so that's the Windows time, I guess. On success, you can do stuff to T there. So this would be the file time. Right, I don't have Windows obviously, so I need to see what the structure is. Load date time, high date time. So somehow got to convert that to an integer of some kind. I don't know. Yes, that's just meant to be like two 32-bit ints, isn't it? I wonder if you can convert that to some kind of shared time. Basically do similar to what stat does, I guess. Right. Someone seemed to have asked it here. Ah, Avik, thank you so much, sir, for the raid. Appreciate you. How's it going? Welcome, raiders. Hope you had a good stream. What was you working on? Today we're adding shader binaries to the system here so that we can load in different shader binaries into our game. So we just have one at the moment, which has all of our shaders in it. And we're just trying to add support for loading multiple for things like assets when we want to make our own materials and stuff. So essentially it's like a way of doing plugins but with shaders. And then we are adding support for hot code reload. So we can get stuff. Yeah, so we can can I just run this? Yeah, working on hot code reload, so we can reload shaders and not have to restart the game because we're building a material editor which will be running off of shaders basically. So this is our game so far. It's just a bunch of spheres and stuff. We're just trying to get these ellipsoids to have materials, more than just a basic PBR material per ellipsoid. We want to try and aim for having like textures basically, all textured PBR. Went from one stream working on a game without an engine to another one. Oh yeah, this is the way. Pretty good so far. I'm wrapping MGUI with my own APIs so that I can work more easily with layout and stuff. Right, I see. Yeah. Yeah, MGUI has its own way of doing the layout stuff, doesn't it? It's a little bit weird when you want to make stuff like right aligned as well, isn't it? Or something like that from memory. Or if you want to like put your label on the left hand side of stuff, it's like, yeah, it's a bit fiddly. But cool, awesome. So how long have you been working on your project for? So we're trying to convert this file time to a Unix time. Answer this very question on this blog last year. Of course he did. Amazing. Thank you, Raymond. Raymond Chen. Oh, come on. Why doesn't the link work? It's like a fake link. The answer is to use Chrono. What? No way did Raymond Chen suggest. Oh. Yoink. See, this person knows where it's at. This person hasn't got a clue. Apparently this does it. My concern is that there's two fields. Oh, right. I know I was doing it. There's a low and there's a high bit. Oh. Windows. So that converts it to Unix time, which just gets us in seconds. It's not nanosecond resolution, is it? But that's okay. Is there a better way? Is there a better timestamp than Win32 file timestamp? I guess let's just get file time. We'll just use this one for now. That'll do. Last year I spent developing my own render framework. Cool, since January. Right. Let's see. Cool. Is it like a 3D rendering framework thing? Something like that? Okay, so I think what we can do is just say t dot seconds equal that. And that's all we can do. There's no nanosecond resolution, I think. Let's just see how that rolls. Anyway, we're not on Windows right now, so... But this ought to be good enough. Right, finally then we've got this sort of timestamp thing. So we've got to be careful though because of my core side of things. I've not fully implemented my time API yet. So we do need to go ahead and get that thrown in here. Just quickly get in there and do that. This should really be an OS thing. Oh, why is it in the core? Well, the time now is like an OS thing, but still. Yeah, it's all OS. Right. Let's go and correct that. So this time. Okay. And then radio. Right, that was it. Good, good, good. So let's go ahead and take all of this and then implement it in, well, next to here, I guess, in the OS side. Oh, this is OS Linux. So the os.c should be able to contain this, except for time now. Time now will be a thing which gets done. I really don't want to implement all this today. I want to get the we need probably some comparison operators as well. These things. Hey, Payenzin. What do I do for work? Well, I work as an engine programmer full time in the industry. I work from home though, so I do like 3D graphics and stuff, and engine programming, that sort of stuff. It's basically a little wrapper around Vulkan DX12 Metal web GPU that I can use to render stuff. No, high level logic or built-in rendering sequence. Cool, awesome. So have you actually got it ported to all those different platforms as well? That sounds pretty great. It's always great having your own code. Amazing. Right, so we probably want a way to compare as well. So if you take the difference between two times, or you probably want a way. You probably just want a way to say. Probably just check equality, maybe, or. Yeah, so let's just do some basic like comparison operators for this, and then I'm just going to crack on back with the actual Vulkan code because, yeah. But when I actually need this at some other point, or if we get finished earlier, I'll come back and do this. So all these are doing. Well, they could have just been in the header, to be honest, right? Could have been static inlines, but don't know. Left hand side dot seconds. right hand side seconds, and left hand side dot nanoseconds, right hand side dot nanoseconds. You get into market, not sure what to do. Okay. So, do you have multiple things you like doing, like programming and art and or music? You know what I mean? You know, or 3D modeling, texturing, you know, or is it that you're into programming but you don't know what sub programming field to get into, like how engine development or gameplay programming or tools development or whatever? That sort of like, which ones of those is it? How sure are you, basically, is the question. Cool. Just a programmer. That would make sense. Wait, let me just double check this a sec. So less than. So if the seconds is less than. Yeah, this would be a bit funny. So if the seconds is less than the other seconds. Oh, it should be fine. Then you just gotta make sure you're less than. No, wait, it's where you gotta be. So if you're less than these guys. Right, I see. It's a bit fiddly. So if you're less than, then you've already passed. Right? Or it's got to be equal and the nanoseconds is less than, right? Yeah, so I guess Payanzin, if you feel like, you know, so there's, it really depends what you want to do. Do you want to, like, if you like having something very visual and you like run up the gameplay side of things, then obviously like being a sort of a gameplay programmer is quite a good fit because you get to be able to, you know, usually write a lot of things where you have lots of visual feedback quite quickly, like quite a lot of the time. So, you know, those are quite popular roles actually in game development. Then if you don't really mind about the whole visual aspect at all, but you really like the low level side of things, you've got an engine programmer. But if you like kind of visual stuff and you like the engine stuff, then there's obviously a graphics programmer. And that, you know, the graphics programmer does require like a lot more maths and stuff, but you can usually get away with just the basic like knowing your vectors and matrices and how to use quaternions. But there's lots of other maths that comes into play, especially when it comes to like ray tracing and stuff and lighting. Hey Lupo, how are you doing? How's it going, Lupo? I am extremely tired. So, yeah, that's about me. Extremely tired. I'm doing okay. I've had a workout yesterday. I went all out and didn't really get the best of sleep. And yeah, so pretty tired right now. It's about it for me. How about you? So I guess if you do the left hand side would be less than. That will return true if the seconds is less than, or they're equal and the nanoseconds is less than, right? That makes a ton of sense. Less than or equal to is if it's less than or equal to on that one, right? or the nanosecond. No, or it's equal and the nanoseconds is less than or equal. Yeah, it's a little bit fiddly, but like that. So greater than is the same sort of logic. Right, so now I've got these things in. The rest of them I'm going to put in, but I'm going to write in core un... Oh, I've not got an unimplemented. Right, core abort. Just something like this for now, because I don't want to be writing this code right now. I want to be doing shader binaries and hot code reload. So I'm just trying to get in at the bare minimum to get stuff going. And I got this stupid unused stuff going on, so there we go. Got to do all this as well. It is useful though, to be honest, not gonna lie. This saved me scratching my head later on, so what can you do? Oh, let's get back. Let's get back. Mode. Already went to the gym? Nah, I don't go to the gym. My home is everything. I eat, sleep, work out, work. All from home. So, yeah, I can't bother to go anywhere. It's just a lot easier. You know, I lift probably on about, what am I doing now? I got about 17 kilogram weights that I lift right now. And I do all sorts of them. I do dumbbells, I do sort of my shoulders, I do my neck, obviously do squats, I do sit-ups as well for the core, you know, got to have a good core. And also my wrists as well. So I'm up to about 17 kgs right now. I'm trying to probably use them for a good while because they're a bit heavy, but I've kind of got used to them now. I can do like 10 of everything. Well, sets of 10 reps on everything with them. But yeah, I also got like a little treadmill as well. I use that as well, so I go all out on that treadmill as well. So good fun. I'm really trying to start designing the game. Nice, very cool, exciting stuff. If you figured out what type of game you want to make, like what genre does it fall into? To release a game for the next fest would be great. Right, yeah, one has just gone by, hasn't it? I think. Well, a few months ago maybe. Not bench press. So I got dumbbells. So I got 17 kgs in my left hand and 17 kgs in my right hand. That's what I do at the moment. So it's quite alright. You know, when I first started, it was like 10, so it's gone up. The someone, right? That's not a lot of time. Are you using any sort of libraries to get that thing going? Okay, so we can finally get out of this OS code and get cracking on with stuff. So the idea is, right, in GPU internal, there's a shader binary and it has a timestamp. OS time. This is the last time it was modified. Yeah, easy. So in the GPU side of things, whenever we create one of these shader binaries, we go right. Equals OS file last one of these guys, spec path. Jobs are good. Oh, now the next thing to do is to go over all of the binaries and just check if it's been modified. Wait, how are we going to do that? Oh yeah, you get a new one, which means we've got to store the. Hang on a minute. Which means we've got to store. Now this could kind of be invalid. It could return 0. That's okay. That's fine. That is safe. So if there's a success, we're going to say binary, and I guess we'll use the static allocator or something like that. Just chuck that in there like so. So path equals core string format. Static allocator. Just chuck it in. And then we can say I gotta clone those, isn't it? Clone also works, should be quicker. We need to really include that null terminator since it's a path. How do we get to achieve that? I guess I'll add another one. So with the null terminator. Nice. So, right, the next idea is to say, we want to say, probably have an internal function to basically just say try reload. So that will end up calling into GP backend reload, passing in the binary like so. So we need to do a get. Then you need to say, right, so you have the new OS time. New modified time equals OS file last modified time. Binary path data. If OS time, if this new time is greater than the old time, okay, we say it's less than or equal to, then we're going to return and do nothing. If not, it's greater, and therefore, it's the other way around. Oh wait, that's right, isn't it? Yeah, so then we'll say we'll update it with the latest one. Very nice. So now we've just got to go over all the binaries. Sorry, all the shader binaries. So, well, so there's never a time where you want to say reload. Right, you might want. You might want the ability to be able to force reload, to be honest. That does sound pretty does sound like it makes a ton of sense, actually. So in that case, you would just simply to update the last modified time and then just call reload right away. Now this one here, we'll just need to do a loop and yeah, so then we need to declare the shader binary ID. It's just a demo, not a full game. Yeah, I'm learning, so using Unity 6. Cool. For the full game, I think 1 year, maybe tops. We'll see. Thank you for catching that. Yeah, so I don't know, just be careful. Like, I'm really bad with estimates too. Like, if you're going to do an estimate, make sure you plan everything out to a T, right? And then times it by 2. If you're just thinking in your head and you haven't thought it all out in any way, times it by 4. Okay, sorry, let me rephrase that. If you haven't planned out, like as we did last stream with this material thing, so we wrote this whole material plan where I planned out basically how many streams each thing would take, each feature needed, and try to drill down into it and think about it as much as possible. If you've done a plan like this for your game, if you take those numbers, times it by 2, that'd be fine. If you haven't done that and you've literally just thought about it, think about it as much as you can, and then probably multiply what you're expecting it to be by 4. Estimating stuff is very hard. Things just pop up and make it take even longer, or you change your mind on things as well. So if you're trying to aim for a year, I would try and say aim to make a game in a month. And then that will probably, or even 2 months. A 2-month game, plan out a 2-month game, and then in a year you'll definitely have that game done. Like, if that's what you really want to do, is get a game out in a year. Very easy to overscope stuff. Right, so we want to basically do an iterator over this. So I've got an iterator API, it just goes, it's like a linked list. It's not the best, does the job. So it's just a while loop over an object pool, iter next. Yeah, I do these things very rarely, but it's just easier sometimes. I only really do iterating over an object pool with a linked list when it's like debug stuff, basically, in editor features typically. So in a shipped game, we probably wouldn't have these types of things. Where are these ×2, ×4 coming from? Like school level budget or just life? Oh, 100% just life. So I can tell you that I've been programming for probably about 14 years, and my estimates are only really good when I've done it before and I've planned it out, and yeah, and I'm not using someone else's stuff, right? That's when I can do good estimates. or and when I'm not sort of in a work environment where I've got like meetings or someone comes up to me during the day and then, you know, or a bug gets thrown my way and I get detoured, right? Lots of unforeseen circumstances that just throws like a wrench in my gears of being able to estimate. So that's the only, so those like 4 things that I listed is only when I can produce good estimates. So estimating is hard, and so whenever you think of a plan or whatever, that's an ideal plan. You have lots of stuff pop up. You'll have, you know, you'll change your mind on things. The thing will be more complicated than you initially thought. The times in by 4 is definitely safe in that case. But if it's your first game or whatever, I would say aim for a month game, and you'll get that definitely done within a year. Ready to be released. But if you want to get a game out in 6 months, aim for a 2-week game to 1 month game, somewhere in between that range. For a year, 1 month to 2 months. Right, this is a pretty okay function. So I guess we'll just stick this. We'll make it a function like that. So when we sort of start up the, let's say we'll do a frame begin. Hopefully 4 times is the worst case. Maybe. Like, usually, yes. Right, so every time here, during debug mode, basically, we'll just do this. Go over all the shader binaries, check the modified date. Now, really, we shouldn't do this every frame. But yeah, we can always improve things later. Hey, Ketamore, how's it going? Have you ever played Race Son of Rome? Sometimes I wonder how come that game came in 2013 and looks infinitely better than games made in UE5. So my question is to you, why not limit yourself to the rendering and lighting techniques used in that game? They're good enough, I'd say. Interesting. Alright, see you later, Lupo. So you bring up a really funny point, right? I'm not a fan of TAA, right, and all this temporal stuff going on, right? But the game you just mentioned, I only know about because I was like, what was the first game that brought TAA into existence? And supposedly it was that game you mentioned. From my very quick research, this was the initial game that brought TAA, temporal anti-aliasing, into the first game to implement TAA, right? And you know, all of those sort of TAA temporal anti-aliasing effects. Sorry, temporal anti-aliasing games, basically, you know, they have like lots of ghosting and everything because people basically try and like upscale with it and all sorts. But yeah, I suppose these guys didn't try and upscale with it, they just used it for anti-aliasing. And so they got the sub-pic when they did the jitter and rendered 4 frames that was slightly offset. They would get sub-pixel information and they wouldn't necessarily be using it for upscaling, right? So make the edges look, maybe it would minimize the ghosting as well. I'm not sure, to be honest, because I've never really written a TA. But yeah, I don't know. I can take a look at it. You know, yeah, games these days use a lot of like ray tracing and everything, and they run slow and oftentimes use algorithms that produce lots of noise, right? and then you have to run denoisers, and denoisers are temporal, and produce a lot of ghosting and everything. So yeah, we very much like to avoid all of that. That's something that we probably want to start doing next year after we've done all this round of editors and rendering, is probably start off the next year with lighting and figuring out what we want to do there. And because after this year we'll have a whole scene that we can build. We'll have an editor where we can build models, materials, and small little levels, like a scene that we can test stuff in, right? So then lighting will be the next thing to do. So yeah, I'm very much trying to think what would be ideal. I don't know. We'll have to see what sort of game we want to make as well. A lot of the old games just pre-lit the scene into light maps or probes, right? And ships the probes on the game, shipped the light probes on the game and stuff like that. So, sorry, on like the game disc and stuff like that. Yeah. Whereas the ray tracing stuff these days is like it responds in real time, but it's kind of not instant. It's like accumulated over frames. There's like there's a bit of a lag to get it fully, resolved as you would. So yeah, there's things to think about and basically investigate, right? Try and implement some of these things and see if they like them. Awesome, and yes, I agree with you. I'm not that knowledgeable, but I know that a lot of people think the latest graphics techniques aren't the best, and even in Unreal Engine 3 look better in some cases. Yeah, they will use these days the industries like use FSR, there's the NVIDIA one, which is like AI upscaled, and it's a bit sad really, because we're basically rendering at 720p and then upscaling to like, I don't know, 1440p or maybe even 4K, and it doesn't look great, right? It's a bit like when you go on Netflix or whatever, and they say they're providing you like a 4K stream, but they're obviously compressing the crap out of it. Now, probably Netflix isn't that bad, but if you go on Prime Video used to be really bad for that. You used to literally see like big black blocks show up when you was watching like a very dark scene. So, and kind of we have that in gaming in a way, but it's not compression, it's more of upscaling artifacts, right? Because it's the source image is actually a smaller resolution. So yeah, it would be good if we didn't be we won't be doing on this. I think these days GPU vendors want to literally just they want to improve on AI technologies and ray tracing technologies, which is two areas where the programmer has no ways of doing it themselves. It's this very specialized hardware thing which does the job for you. With the AI one, you just implement their SDK. With the ray tracing one, sure, you get a few shaders, entry points or whatever, but it's this weird abstraction of acceleration structures and whatever you have to wrestle with. But yeah. Right, so I think we're there now. Oh no, there's the dispatch as well. The dispatch has got to change. We're missing those ones. And so then we can focus on the Vulkan side of things. Dispatch. So with dispatch now, we've got a couple new functions. Oh, we used to get the shader names from there as well. Oh, we're going to need the shader names. Oh well. Shader index. Now there is going to be another function, and it's called from binary. GPU shader binary. Like that. Cool. So this allows us to dispatch from different shader binaries, but the default one will still be very easy to use, which would be cool. Right. Binary ID. So we've got to have a way. Got to change that dispatch thing. Right, shader infos, we've got to sort that out as well. That shader metadata is coming from here, isn't it? The interop. That's not it. Right, GPU.h, we'll get rid of that line there. Good, good. Right, so we've got to have an array of names, so we can put that into the, I think this will be for texture viewer, I think, to use that. Right, just take a quick break. Be right back. Right, welcome back everybody. So when we create that shader binary, we're going to want to keep note of all those names. I did avoid putting it in here, but we're going to need it. So we need a array of shader names. So we need a shader count in here. Shaders count shader names Boom. So we already have them. It's just a for loop over. Where is it? Okay, so shader names core allocate array of core string, and it's going to be in spec shaders count, right? And then binary shaders count equals spec shaders count. Nice. So what I'll do is just do a nice little mem copy. Well, we can't do a mem copy because there are a bunch of char stars, isn't it? C strings. So we've got to go ahead and just do it manually. So we shader names index equals core string clone. Yes. Now we keep, allocating, deallocating stuff. It's gonna, we keep initializing shader binaries and stuff and deinitializing them. Then they will static allocate too much and it will crash, but we can sort that out later. I got an issue with in the material editor. If we add any new textures, they're going to need to reference new shaders. That's a good way of saying it. They will, right? So you make a change to the file, you do a reload, like it'd be great if all the names were automatically assigned, but then so if you add a new text, you'll probably have to do a shader binary D in it and then reinitialize it. That can work. I think that'd be the way we just work around it for now. So it'd be a clone spec shader entry point names. That'll do it. So, right, that's good. So now inside the dispatch function, when we dispatch a compute shader, we can now reach into binary, shader names, and then pass in a probably want to say .data, and then we can probably null terminate it as well, maybe. Right. That's good. So then dispatch from binary. There's another one. Indirect dispatch from binary. Same thing basically. Okay. So that's all the front end work done. Now it's just a case of all the back end stuff inside the Vulkan backend. So when we initialize, so I guess we'll go backend.h, pick up these things, and then find radio. So if we look out for shader module, wait, let's go to Vulkan internal first. So we need probably a shader module, and you probably need an array of all of your pipelines. So I've just got to find, here we go. There's one for the resource, this one for shader. Do one for shader. Or it doesn't have to be equal, it could be less than or equal to, I guess, but there we go. So shader binary, this is gonna have, it's gonna need a VK shader module, because that's what it maps to basically. Then we need an array of VK pipeline. So it's just an array of pipelines indexed with the shader index. Okay, that's all it is. So that is just a case of 2 pointers, that's 16 bytes. Done. Rightio. So we need a way to be able to get one of these from a shader binary. So I've got usually a little handy function to do that. So we need to copy paste that, pass in a shader binary. So, you know, there's this sort of like back-end data, which is just an array of bytes, but it's aligned to a specific alignment basically. And we're just going to return that, the address of that casted into this back-end thing, so that the back-end type is not directly exposed to the front end. So, yeah. There we go. So inside though, wait a minute, inside binary, there we go. So we can now just use this. I guess we call it backend typically, or binary backend, I guess I'll call it. Nice. And now we can go ahead and do the allocation stuff. So I need to get another static allocator. Just pull that in. Now we're going to go ahead and allocate a dynamic array of pipelines. So it's a core alloc array of VK pipeline. We're going to use a static allocator for now, and then it's going to be the binary, well, sorry, the spec shaders count. Okay. Now, if we go look out for VK create shader binary, sorry, shader module. This is where we do it currently. So we're going to take all this and yank it out. So this is for the one that was just hard coded in there basically, and just drop it in here. So we get the code by reading in the full file. So I'm going to read in the full file like so. Spec shader path, and read all the code out. Spec path, yeah. Now if this fails, we've already got an assert outside of this for the main one, but the rest of them can optionally fail. So if you fail to read it all in, we shall just return false. Now on success, we create the info. And again, this can fail as well, so just got to look at that. So vk create shader module. Wow. So the crazy thing about it is, there's no error code. There's an invalid shader error for NVIDIA, but that's crazy. There's no way to... So if you got an invalid shader binary, it can just crash your program. So how do you check? Because I want to maybe in the future allow someone to put in a custom shader binary or whatever, and if it's an invalid one, it shouldn't crash, right? Yeah, there's the validation layer. That's bananas. How can there not be a way to check if there's a valid shader binary? Right, so the way you do it then is you run it through spearv val before you call this. Right. That's crazy. But anyway. That is nuts. Yeah, so we probably want a way to run it through spearv. Ah. So when the editor's enabled, probably allowed to run it through spearv validation, which is a separate command line program. Anyway. Okay, so this just, we're compiling all of our compute pipelines now. We've got a special thing here to say we want it all to be in like wave 32 mode. And I need a VK result. Hang on a minute. There we go. And so create a compute pipeline. We go over all the shaders. Yeah, spec. Shader entry point names. You create the pipeline, then you set the object name. Nice, those can maybe fail though, but okay. Well, we'll handle those when they become issues, I guess. That's going to create all of those there. Now on a DNet, we want to make sure that we basically defer delete all of this. I think I've got a defer delete system. Yeah, so I need to add a new object type, or two new object types. We need to add Vulkan shader module and pipelines. So when you dinit this thing, it could still be use this frame or something like this. So you probably want to defer delete it. So we'll probably chuck on that defer delete queue. So you'll say something like defer delete binary. Oh wait, we've got to get the back end. Oh, and I didn't. binary backend. Right, which makes me think we've got to close all those up. Okay. Binary backend shader module. Good. Shader module, and then we're going to go over all those different shaders and defer delete all those pipelines. So 2 frames later they'll get destroyed basically. So if we've kicked off a frame and it's decided to reload or whatever, then that should all work out okay. Nice. Right, and the next thing would be... Right, so for the reload, you probably want to... You know, we could call the deinit side of things, but... maybe we'll do it separately just for now. It will be duplicating code though. It will kind of suck. So we could have a function which just... Or maybe we can split these into 2 separate functions. So we have so maybe sort of like static init objects. So it just initializes the objects. We probably don't need the spec at this point. Yeah, it's true. Yeah, the problem is the entry point names won't be initialized yet in the other. All right. Okay, so by the looks of it then, you would allocate the pipelines and then just call GPU backend init objects with the binary in there. We shouldn't have to pass the spec in actually, thinking about it, because I've just made it not really need the spec anymore. Right, so the reload should just basically be deinit objects and then create the new objects, right? That should be the basic idea. Nice. So now outside of this, back into GPU land. Unfortunately, so we're going to basically waste some memory here if it fails. We've got time to make the code better later, right? Let's just get stuff. let's just implement all the stuff we need first. We can come back and do a second pass over all the code. So I don't need a spec to be passed in. So create all these allocations and get them prepared, and then init. Okay. Right, so that's the shader binary initialize, deinitialize, and reload done in the backend. Anything else changed? Well, there was the dispatch, wasn't it, right? So in the backend, dispatch is taking sort of HCC shader. Now it should only have to take in a GPU shader binary and a shader index. Right, we're nearly there now, and we should be able to try this thing out quite soon, I think. We just got to do this, these two functions, and then the initialization code within the game itself, because the game has got to point to the original shader binary, and then we can test out the hotcode reload and see how that works. So all we're going to be doing is getting from our binary. Now we could probably index out of bounds here, so we probably want to put some kind of assert so it just doesn't crash randomly. You know, if you try to dispatch something in, yeah, we're better off just making it crash for now. So if binary shaders so you got to make sure that the shader index, okay, I've gone out of bounds check. Array bounds, shader index, and binary shaders count. So we'll just do that, and then it's just as safe as Rust, right? And then binary shader names. Oh no, sorry. I've got to get that backend binary structure. Get the pipelines for this shader index. Cool, and then we put a profile scope around here so it gets a nice little name in the profiler. And we do the dispatch. So yeah, that would just be a binary shader names dot data, I think. Rightio, then we just got to do the dispatch indirect. Nice. Cool. Right, so the only piece we've got to do now is in the main game, when we kick off the GPU init, we just got to fill in the new fields here. So shader binaries, let's say we can have like 1,000 of them for some reason. Oh, let's say 256 then. Then let's say shader binary. Now I've got to put all this all in here. So it'll be shader binary shaders count is equals whatever. Now there's the HCC interrupt stuff. So if we go look for include dot build slash HCC shader dot h, I think. I forget these things. Shaders metadata. So the compiler, when we compile shaders, outputs metadata as an option, and so it puts all the shaders in an enum, which is pretty handy, and does some other stuff that I'm hoping to be using to do automatic sync code and stuff. But yeah, we've got metadata about these. So we've got the names in here, right? Unfortunately, they're not in a nice array, which would have been better, I think. But So we get the compiler to emit. If we get the compiler to emit an array of strings, then it would actually be useful for this thing. I wouldn't have to create another. Maybe we can quickly go over to there and get it to do that. Although, yeah, let's do it. So I think it, wait a minute, let me just double check. Okay. So inside the metadata file, is that right? Metadata gen. We already kind of, so we just gotta repeat this loop here basically. So I think we'll just output like a const char star array. Function name. Ought to be good enough, right? So we were just to do that. That'll really help. Which means I've got to go over to down Windows again. Oh, for crying out, what is this? What are you talking about? When did that happen? Well, did I accidentally delete a... I don't know when that happened. But anyway, in core C has been messed up somehow. 690. Wcast function type mismatch. Is casting between function pointers like not allowed anymore? Like, what's going on? To me that looks right. I think though they've got this sort of like start routine thing. So what's up with p thread? Has this changed? Alright, that's the name they gave it, right? P threads. What's going on? Am I not allowed to cast? Incompatible function pointer types passing. You know, I know. There's something with function pointers in C where sometimes they're not safe to cast between. I think this is what it's complaining about. I guess we have to just say no. Just tell the compiler no, basically. Bloody weird. Right, let's just change it in the build script. Can't be asked to fight this. -w this thing no dash. That'll do it. Maybe not. Right, it might be dependent on the order. So it came in on extra, I think. So there you go, that's done it. You got to put it after the extra because extra brings it in. Right, what is this? Okay, so metadata gen obviously calls them with the same name. Right, where does it get this from? It's an option, shader info's name. What's the default one? Shader infos. Right, I'll just call it shader names. Now. Well, I could always just add another one in. Right, so there's a couple of places where this goes. Shader names, name. Cool. shader names name. Right, let's give that a go. It should give us a new binary. So I should just be able to copy that over to... Nice. Over to the engine. Now in the engine we should just be able to... What should we be able to do here? Right, so when we run the build again, so scripts build, excellent. We should get, we reload this. Wonderful. So we've got HCC shader names here. So this is what we want. Now inside the main file, we should just be able to chuck in the shader names here. So the shader count, shader binary entry point names, shader names. And I guess I can do core array count, shader names like that. And there you go. Cool. So the next thing to sort out here is apparently all these errors are showing up because we're using this sort of HCC shader is not declared, and that's because inside the graphics module we need to basically include this header file into here. Alright, we're getting pretty close. Oh crap, we didn't do the defer delete, so thank you for this, for doing that. Hey Rohan. Yeah. It's the number's getting big, isn't it? So if we're looking at stats, that's like, it's over 2/3 of the year in terms of days, but those days are also not really full working days. So, I think when you... So I think if you used to put this into months on how many sort of working months I've put into it, working 5 days a week, say, it's probably over 6 months at this point. So something like that, which has been quite good because we've just done a bunch of like R&D and stuff and got quite a lot of stuff in here. So it's pretty cool. How's it going for you, Rohan? How's the FGP? Sorry, I'm so I'm so tired right now. Words are just, yes, they're a bit strange right now. So how's the FGPA world? Sorry, FPGA world. That's it. There we go. How's that been going lately? Man, I'm so tired. I need some sleep. But we're nearly there. So shader binary, yeah, those need to be able to be these errors, yes. Okay, so Vulkan 1074. I forgot to defer delete the shader modules and pipeline objects. These are pretty easy. So when we defer delete, it just sets that VK handle field with the U64, and because it's a union, the rest you can just cast into what each of these quite easily just by referring to it as a different field, and jobs are good. Pipeline. Right, soon we're gonna have hot code reloading, which will just be so helpful. And we've kind of done a lot of shader work already, but there's going to be plenty more, I'm sure about it. Is this Marcus from... IKEA. Who's Marcus from IKEA? Are these like adverts or something like that? Do you have any problems with static electricity because of Marcus? I have been having problems with static electricity. But that's probably just because it's winter. We're missing some of the function prototypes. Module and pipeline. There we go. Jobs are good. So what's left in here is the spec for 2305. Spec path, radio. And dispatch. Command dispatch. GPU 1403. I didn't pass in the shader binary. Okay, so let's give those a go. Oh crap, that one's missing HCC shader as well, isn't it? Build. Oh, this chair. Yeah, I guess it is. I think my dad bought it for me years back. He was like, you know, he was saying he's got some chairs that are good, so buy me one. I think this is the one from IKEA. I think quite a lot of people have it, yes. I don't get the static electricity from it, though. You get the static electricity from other reasons, I think. Just regular day job. Put FPGA work on hold for a few days. Oh, okay. It's alright. Nice. So I guess it's been quite hands-on at work then, quite busy. All hands on deck. Some important stuff going on. What the crap is going on here? It doesn't return true. Right. And this can fail as well when it tries to reinitialize, which would be a bugger. Right, so if it tries to initialize and this fails, well, yeah, so it'll fail if you can't load the binary in, right? So you should be able to pass in the code. Yes, I think we would put a void there, but these could fail and it. Ugh. It's the right pain in the butt. Screw it, let's just let it optionally fail. Well, potentially fail on reload. I can't be bothered to make it perfect. Right, here we go. So, when we finally booting up the game, it's crashing in 710 for what reason? Right. The path must be invalid for some reason. Oh, there's no shader path actually been set. Rightio, so in main, we did forget to write shader. Ooh. Binary path. Right, that one is currently it's in build / shaders.spv. So all our shaders are just in there. Alright, let's give that a go. Hooah. Right, so we crashed somewhere else. A little bit weird going on there, so let's run that. Right, this is a better one. Init objects. Alright. Why is this one failing? What's code? Seems alright. Why would it crash here? So I've got the validation layers on, right? So I think so, right? Yeah, validation layers get turned on automatically if they're there. So we're getting some weird. Excuse me. Oh, what is that? Shaders.spv. Oh. What are these? Oh, that's me putting a link in. Oh, it links to this one. Yeah, because I think it wanted like a spivvy thing at some... Right. I use an incorrect file extension for it. And then so program wanted it, so I just decided to symbolic link it. For some reason. Okay, so what's the problem then? So it should... It should be loading in... Like this code ran fine in the past. Is the device... the device hasn't been created yet. That's why. Gotcha. So gpu.c, where we call this sort of shader binary init. We want to call it later on. That is for sure after we have instantiated the backend. So init, backend init, plop that in there. Woke up early, it's 3 in the morning for me somehow. I've to make room for... Yeah. Yeah, get... Have you got multiple side projects? Right, so it appears we have success. Yeah, it's very easy to get multiple side projects, right? All the side projects. You have to find time to exercise there, you know what I mean? Right. So now here's where the fun begins. Let's open up. So let's see if hotcode reload works. So we go to the shaders file, right? And we now run, or we find the encode to surface. We're just going to poke the red channel to 1. All red. Now if we rerun the build script, see what happens. Okay, the game crashed. But it looks like it was this is great. So code size must be greater than 0. So for some reason we tried to load it in before the thing was finished being written to. Right, this is a classic problem. So yeah, we need to say if it's changed, probably sleep a little bit. It's not the best, but I guess we can do it for now. But at least we know that kind of worked. Yeah, what should we do? So last modified time, if that change, so this has changed, then what we can say is like, well, sleep 1 second, I guess. The problem is if you have many of these, it'll be a bit of a bugger. There is usleep, but also Windows doesn't have this function, I think, so it's a bit fiddly. So the other way would be yes, the way to do it. Let's just put the sleep in there for now, just to get it working. Okay, so we're going to change the red channel of the final thing that puts to the screen and put it to 1. So we'll still see some other colors show up, but the red would just be overpowered. And that will test out the hotcode reload. So red channel 1, right when we code it to the surface. We're going to do a reload. Oh. Here we go. Right, that still failed. Must be a valid handle. $10.98. Oh. So we passed in a null handle on the deferred delete. Ah. We didn't index by the shader. Cool. Well, how could the 0, 1 be invalid then? Very skeptical about that. Oh well. Right, let's give that another go. So it's going to give us a really weird image. Now hopefully we can fix this weird image by removing that change we made, running the build function, and oh yeah, hot code reload. There you go. So we do have to run the build explicitly though, but this is something that I hope we could automate in some way when it comes to the materials at least. So yeah, we could just live change stuff, which is pretty handy now. It's pretty sweet. Nice. So we can just change these spheres, for instance. We can go to the surface, calc surface color, and we could probably just, poke around with this a little bit. We can go oh yeah, the material, that's it. So we can then now go material dot albedo. What is that? Unpacked color? Right. We go, well, this one is red, blue. So red, green. Let's say 50% green. Right. Then we just rebuild, and we've changed the spheres. Nice. So we haven't really built this to change shaders live, like these graphic shaders, but we're definitely going to be using it from now on. We built it so that when we have the material editor and we generate materials within the game, we can then just write some shader code, hit save or whatever. The game will recompile the prototype material. That prototype material will just basically make a ton of textures. Those textures will be the PBR materials for these spheres or these ellipsoids. And we'll have a specific editor where you can sort of view all the textures that get made and also the final sphere that it gets put on and stuff like that. So that's what we're building over time. We're going to build over February all of the stuff behind the scenes, and then in March we'll build out all the UI and get it all together and working. So last stream we made a little plan, the material plan, where we went over everything and scoped it all out basically. So we have achieved this today, like that. So we'll tick it off. So we've got this sort of shader binary thing, multiple spivvy files. We haven't tested the multiple spivvy files yet, but it probably works. It's good enough. I'll fix it when we try and use it. The hotcode reload definitely works though. There's bugs probably, but again, we'll solve them later. So the next stream will be texture cache. So we want to have a way to basically load thumbnails and materials into these sort of 2D texture 2D arrays, and we want to have a way to make it such that we probably want to be able to stream in different materials depending on how close they are to the camera and stuff like that. So you might have some ellipsoids with certain materials on them, but the ones which are larger and closer to the screen will need the more high quality ones, and those will stream in the higher quality material. So we're going to be building some form of texture cache where it's just a bunch of pre-allocated textures where the material textures will just get preloaded into. And we need it for the thumbnails as well, for when we have like a UI for the editor. we need some nice thumbnails to view all these things. So some form of pre-allocated cache for this would be pretty ideal, I think. So we'll be building this out in the next stream. So is this something I want to just finish up on quick? So we did put a sleep in there. I don't know how we can wait until this is probably going to break on Windows as well. Yeah, the modified time isn't great. It's not the best solution. Modified time. So you don't know when it's finished or not. That's the problem. Or the other way you could do it is that it... Yeah. So maybe we just sleep a bit shorter then. Is there a syscall for sleep? A standard library. I want like is Windows is sleep is milliseconds. Clock nano sleep, that's it. Oh, sorry, nano sleep. So nano sleep gets you nanoseconds, right? Yeah. So if we put in a sleep function for millisecond, because Windows has capital S sleep, right? Windows has capital S sleep for milliseconds. Is there a high resolution one? Has no resolution higher than the current time resolution, typically 16 milliseconds. By minimum 1 milliseconds. Oh, sketchy. And then you got to use a busy loop. Wow. So 16 ms. That's bananas. Anyway. There must be a better way to sleep on Windows, but there's not. So maybe we'll chuck in like an OS sleep milliseconds to sleep for 1 millisecond maybe. We'll just throw that in. So os.h. So what is Windows sleep? Get out. Keyword milliseconds. So on Windows, that'll be here. So we can just use sleep. Now we've got to try and set the resolution somehow. I don't know how we do that. Then on Linux, It'll be nano sleep. Or I need a time spec. So seconds would be yeah, so you gotta round up to the nearest. Yeah, okay. So you want to do seconds is equal to milliseconds divided by divided by thousands of seconds, milliseconds, microseconds, nanoseconds. So divide by 1,000 gets you into seconds. Right. And then you mod 1,000 and then multiply by 1,000 gets you into microseconds, nanoseconds. There's a way to get back a remaining as well. That's interesting, get back a remaining. That'll do for now. So we can just use our sleep here. And that'll work. So just make a change to the shader code again. Just put 1 in the red. It's too quick. So yeah, 1 millisecond was not enough. So say if we waited... Wait a minute. Has elapsed or delivery of a signal that triggers the invocation of the handler in the calling thread or terminates the process. Huh. So you sleep will be maybe better. Yeah, you sleep is going to be better because the other one can come out early. All right, let's do, I don't know, 64 milliseconds. So inside OS Linux, let's instead use sleep and then do, so that's microseconds. So that'll be milliseconds multiplied by 1,000. Okay, let's try that. . Oh. Okay, rebuild the shaders. Got another crash again. Maybe we do just wait a whole second. Silly thing. Right, let's undo that change and then hotcode reload. Reload and good. Okay. So let's call that sleep function working now. That should be cross-platform. So I've got to go ahead and fix Windows up because we've made a compiler change to output some metadata in a slightly different way. And yeah, we've probably busted some of the OS layer as well, so I've got to get that working again. Right, so I guess we can just git commit this. This is adding shader binary and shader hot reload support. Very nice. So I'll push that up to the code, to the repo. Crap, I forgot to put a tag down on the previous day. Oh well. Wait, I can tag. I can do a tag in post, that's good. Right, so I guess let's find someone's ready for the meantime. So our next be on Thursday at 7:30 p.m. GMT plus 1, I think it is, I forget. It's about 2.5 hours ago, but on Thursday. And we'll be working on the texture cache so we can load in different materials at different resolutions and stuff like that. Preparing for that. So that'll probably take a couple of streams. And then we'll move on to next week. We'll move on to making some changes. So we'll actually load in some texture files and get those, try and use those in the actual renderer, make all the renderer changes to actually use materials from textures instead of having them hard-coded for each ellipsoid. Cool, let's find someone to raid. In the meantime... Hey, there's a C person. Let's go. Oh, I'm so damn tired. Okay, guys, have a good evening and hopefully have a good Wednesday. I'll see you all Thursday. Catch you later. Bye-bye. The C program, ICC, I raid. Bye.